Hey, P-Stats. So I decided to record a video covering the stuff that we didn't quite get to yesterday. And so this will be part of your homework tonight. And so I just did one problem here at the end. Remember, we were having the problem with OneNote, so I was doing it on the whiteboard. But this is a sample problem here. So what we learned is we learned about the normal distribution. We learned how, if you know the mean and the standard deviation, then you can label the axes on the normal model because you know where to go one standard deviation away. Remember those little turning points where you go from curving one way to curving the other way, and um, and so where those turning points happen, that's one standard deviation away from the mean. So in this case, in this problem, the mean was 149 and the standard deviation was 9. And so 149 is in the middle, and then I went 9 up and 9 down, and that's one standard deviation each way. So, and then you could keep extending it out. Try to keep them relatively even. The space in between each one of these marks that I put on the axes should be about the same. Don't get a ruler or anything. Just be in the ballpark so it doesn't look ridiculous. Anyway, so that was and we learned the 68, 95, 99.7% thing, that if you go plus or minus one standard deviation, that's 68%. Two standard deviations is 95, and three standard deviations is 99.7% of your data. And I guess I should say in the model, like according to the model. So if you had this perfectly normal situation, then those numbers would be really, really good. And they'll be pretty close if you have a relatively normal situation. It's just you're not expecting it to be exactly 68% necessarily if you're actually working with real data. The example on that was these ones. If we applied it to this situation, we wouldn't be at exactly 68% or exactly 95% because there's some stuff that's missing. And I think three standard deviations, you actually got all the data. You got 100%. Because it's awfully hard with only this many data points to only get 99.7%. Yeah, in fact, you can't. So anyway, so that's what we did last time. And the only thing we're going to add at the end here is the calculator. So get your handy dandy calculator out. I've got mine ready to go. And we're going to need that in order to do these problems. And so the rest of it is the same math. It's just we're going to show you how you can do it on the calculator. And then we're going to be really clear about what work you need to show. This is kind of critical. Okay, so your calculator can determine the proportion of values between any two marks for the empirical rule. Any of the 68, 95, 99.7, any of those marks, it can do it for you. So you choose second and then the vars button. You can see vars right here. So second vars. And when you do that, you get distribution. Right? So because you can see it in blue right here, distor. So that stands for distributions. And these are all different statistical distributions. Then choose normal CDF. And this is important. Don't choose PDF, choose CDF. PDF just finds individual values, but when we are trying to find the proportion under these density curves, we want the area. Remember that stuff in the beginning about the travel times or whatever it was. I can't remember what that example was. And so we want to find the area under the curve, and CDF is cumulative, and so it combines all the stuff. It adds things up together and combines them into one big whole. So we're only going to use normal CDF. I'll be honest with you, we will never use a normal PDF button in this class because whenever we're using a normal model, we'll want to add areas underneath it. So you choose normal CDF and it gives you the window to the right. I guess I should choose that. And you get a window that looks like this. So what is this stuff saying? It's asking you what the lower bound is and what the upper bound is for what you want to do. Now, there's a variety of ways to do this, and for today's homework, I want you to follow along exactly the way I do it. There's another way you could use the calculator, and I promise eventually you'll have times when I'll let you do that, but not here. All right, so what are we doing? The mean is 150. Here's the 12-year-old girls. The mean is 151, and the standard deviation is 6. So I always like to do 1, and then I see if I have to do more. So I go 6 up and 6 down on the turning points, ish. Okay, so for each of these, sketch the normal model. Okay, I gave it to you for free. Show the mean and standard deviation. Did that. Be reasonable in terms of accuracy. Shade the area in question and find the area using the empirical rule. Okay, what are we doing? We're doing 150 to 157. Finding that area right there. And it says shade the area. This is actually important. I want you to shade it, literally. Find the area using the empirical rule. Then use your calculator. Oh, and find the area. So the empirical rule, we did this one, or one just like it earlier. We said, well, between these two, it's 68%, right? And so half of them would be here at 34 and half of them would be there at 34. According to the model, in real life, results may vary. So it looks like I'm getting 34%. So I'm going to put 0.34. I'm going to leave it as a proportion. Okay, now we want to show you how do you do it on the calculator. Use your calculator to check each of these. And so the lower, and I didn't change something here when I moved some things around. So the z-score, I would have reviewed that and stuff. But we want you to actually put the left-hand z-score as the lower and the right-hand z-score as the upper. What is that? That's just this is the 0 here. This is the mean, and this is 1 standard deviation below and one standard deviation above. This is 2 standard deviations below and 2 standard deviations above, and 3 standard deviations below and 3 standard deviations above. Okay. So, all right. So what do we want to do here? So we want to go from 0 to 1. So on my calculator, because we're going from this one to this one, so in my calculator for the lower, I'm going to put 0 because I'm starting from 151, which is right on the mean. And then I'm going to go to the upper, which is 1. Cool. Leave the mean and standard deviation for tonight as 0 and 1, and you hit paste. So it says here, normal CDF. The first number is your lower bound. The second number is your upper bound. So from 0 to 1, the mean is 0 and the standard deviation is 1. Right? For the record, you don't have to have the last 2 in there. This is for Sam McGee. You could just have the first 2. So you can do normal CDF and you can write it like this by hand. He's just got a different calculator, so quick thing for him. All right, I hit enter, and look what we get. We get 0.341. And remember, that was our answer. It was 0.34. So rounded. So you see, this will do, normal CDF will do your area. I mean, you should still know the empirical rule, but it's helpful to be able to just, to see how the calculator can help you out with this. All right, so let's do one more, and then you're going to finish them up, okay? So what proportion of them will be over 145? Okay, so let's do that. Okay, there's 151. There's 145. So, yeah. Empirical rule, right? I mean, we're repeating some, but that's okay with me. I don't mind. So this is, I don't remember if you remember how we did this in class. Maybe you could take a second. See, can you remember how to get the answer here? But what we said was, well, this has got to be 34%, same rule as above, 68 divided by 2. And this has got to be 50%. I can't remember who said that. Whoever did, nice job. But I remember somebody said that in class. And so all together, it would be 34% plus 50%. So altogether, it's 84%, and that's my answer. Notice I've put the boundaries in, I've shaded it, and I've shown the answer here. Now, but when I'm using the norm CDF, the way we have it set up, so I'm going to go second dister, norm CDF, always C, never the other one. So now instead, I'm starting from -1, so I'll put -1. Remember, we're going to put in how many standard deviations above or below the mean you are instead. Now, what do I put for the upper? This is kind of tricky, right? Because we're going forever and ever and ever and ever and ever and ever and ever to the right. So, maybe I need to put something like, like 10,000, So if you're counting by ones here, and you've got 1 and then 2 and 3, we're going out to 10,000. So we're going way the heck out there. Okay, so what would that give me for an answer? Boom. It gives me 0.84. Looks good. Now, did I have to go out to 10,000? Let me check that out. So I'm gonna bring it down, and I go down into the middle here, and I'm gonna make the number a little different. I'm gonna just delete one of the zeros. So I can hit delete button. That just deletes what's under the cursor and moves everything over to the left. To the left. I'm sorry, to the left. All right. So what would have happened if I had just done this? You can check it. Every single digit is correct. Is the same. So whatever the difference is between going from zero to from the mean to or one below to 10,000 standard deviations above the mean, or 1,000 standard deviations above the mean, whatever the difference is between that is so tiny. This curve is so small that your calculator can't tell the difference. It's off the screen somewhere. And keep in mind that all you have to do is go 3 standard deviations, and you have 99.7% of the data. So if you go 1,000 standard deviations, like there's nothing out there. Let's keep going. What if we took another 0 off? Like, do we have to go out to 100? Would that be enough? Exactly the same. All right, I'm gonna keep going. What if I took another 0 off? So now I'm just going to 10 standard deviations above the mean. It's still the same. And you might be like, Mr. Ellinger, does it ever change? I think you're doing this wrong, and the answer is something different. All right, so I'm going to go 5 standard. Whoop. Okay, I'm going to mess up. And give me a second here. I've got to put the comma back. There we go. And I'm going to go. There we go. I'm going to go 5 standard deviations above the mean. Okay, now the numbers start changing, but not much, right? Like look how many digits are the same. I mean, 3 standard deviations from the mean in either direction gets you nearly all the data. And this thing is so low. When you go to 4 and 5 standard deviations of the mean, above the mean, there's tiny amounts of stuff there. And so for us, generally people go up to 10 standard deviations above the mean. They leave it at that. So when you're using the calculator on normal models, having a z-score of 10, being 10 standard deviations above the mean, is about equal to having a z-score of infinity. Like, it really doesn't make much of a difference. And 10 is like the equivalent of infinity on a normal model, because it goes down so fast. And once you're 3 standard deviations above the mean, you got nothing after that. Okay, you do this one right now. I'm going to pause it. I'm going to write it up. So I want you to draw it, shade it, use the empirical rule to find the area. This one, I think, looking at it quickly, might be the trickiest one we've seen so far. Oh no, it's not that tricky. It's not too bad. And well, no, it is a little tricky. I'm thinking about it. And use your calculator to check your answer. I'm going to pause it, write it all up, and then I'll show you the answer. So now you should pause me. Like now. All right, here you go. So I drew it. I showed the mean, the standard deviation. I showed the shading, and the boundaries are clear and where I'm finding the area. And then I showed that I did the same trick we did with the empirical rule to say that this half up to here, up to there, was 47.5%. And then there's a little extra at the end here that was, I could use that 68 over 2 that we did earlier, and that's 34%. And so altogether, it's 81.5%, or 0.815 as a proportion. I can go to my calculator and say the lower is -2 and the upper is 1. And then I can hit paste and enter. And there we go. Now you look at that and you go, hey, Mr. Ellinger, that's 0.818, not 0.815. Remember, the empirical rule is an approximation. It's around 68%. It's around 95%. It's not exactly. And that you can see that with the last one, and we can squeeze this in. How would you use your calculator to check that about 99.7% of the population in a norm model is within 3 standard deviations of the mean? Well, I'm just going on norm CDF, norm CDF. I'm just going between a z-score of -3 and a z-score of +3. If you go 3 standard deviations below and 3 standard deviations above, you get 99.7%. Not on the nose, but pretty close. So that gets me the empirical rule. Finally, I'm running out of time, but I'm going to try to squeeze another one in. Like if I go -1, I can just get this one, I think, to 1, then boom. I get 68.2%, but 68% is fine. And the same would work with 95. I'm out of time. So thank you and enjoy.